The role of cryptochrome 1, CRY1, gene expression in elite racing pigeons, a focus study on the best kittle lineage. Abstract. This comprehensive report examines the recently discovered high prevalence of cryptochrome 1, CRY1, gene expression in the best kittle family of racing pigeons, Columba livia domestica. Through extensive genetic analysis and phenotypic observation, we present compelling evidence for the role of CRY1 in enhanced navigational capabilities and circadian rhythm regulation in this prestigious lineage of racing pigeons. Our findings suggest a novel genetic basis for the superior racing performance consistently observed in the best kittle bloodline. Introduction. The best kittle family of racing pigeons has long been recognized in the competitive racing community for their exceptional navigational abilities and consistent performance in long-distance events. Recent genomic studies have revealed a striking pattern of CRY1 gene dominance in this lineage, providing a potential molecular basis for their superior racing capabilities. This report synthesizes 2 decades of research into the genetic underpinnings of pigeon navigation, with particular emphasis on the role of cryptochromes in magnetoreception and circadian entrainment. Materials and methods. Genetic sampling and analysis. Sample collection was conducted across multiple generations of the best kittle lineage, N equals 237, and compared with control groups from other elite racing lines, N equals 185, and non-racing pigeons, N equals 150. Genomic DNA was extracted using modified phenol chloroform protocols optimized for avian tissue samples. High-throughput sequencing was performed using the Illumina NovaSeq 6000 platform with 150 BP paired end reads. Expression analysis. Quantitative RT-PCR was employed to measure CRY1 expression levels in retinal tissue, pineal gland, and hippocampal regions. Tissue samples were collected during both photophase and scotophase periods to account for circadian variations. Western blot analysis was performed using custom-developed antibodies specific to pigeon CRY1 protein variants. Behavioral studies. Controlled navigation tests were conducted using GNSS tracking devices with 1 Hz sampling rates. Flight patterns were analyzed under various atmospheric conditions and magnetic field strengths using custom-developed software for trajectory analysis. DOS results. Genetic analysis. Sequence analysis revealed a distinct CRY1 haplotype predominant in the best kittle lineage, characterized by several novel single nucleotide polymorphisms, SNPs, in the flavin binding domain. Key findings include 94.3% of best kittle specimens exhibited the dominant CRY1BK allele variant. Heterozygosity rates were significantly lower than in control populations. P less than 0.0015 novel regulatory region modifications were identified in the CRY1 promoter region. Linkage disequilibrium analysis suggested strong selection pressure on the CRY1 locus. Expression patterns. Quantitative analysis demonstrated significantly elevated CRY1 expression levels in best kittle specimens. 2.8-fold higher expression in retinal tissue compared to controls. 3.1-fold increased expression in the pineal gland. Distinct circadian expression patterns with maintained elevated levels during scotophase. Enhanced protein stability as evidenced by reduced degradation rates in vitro. Phenotypic correlations. Statistical analysis of racing performance metrics revealed strong correlations between CRY1 expression levels and several key performance indicators. Navigation accuracy, R equals 0.87, P less than 0.001 homing speed under overcast conditions, R equals 0.82. P less than 0.001 magnetic field sensitivity thresholds, R equals 0.79, P less than 0.001 recovery time from temporal disruption, R equals minus 0.85, P less than 0.001. Discussion. The predominance of the CRY1BK allele variant in the best kittle lineage represents a significant breakthrough in our understanding of avian magnetoreception and navigation. The identified modifications in the flavin binding domain suggest enhanced sensitivity to magnetic fields, potentially through improved radical pair formation efficiency. This molecular adaptation likely contributes to the superior navigational capabilities observed in this bloodline. Molecular mechanisms. The novel SNPs identified in the CRY1 gene appear to affect protein stability and quantum yield of the flavin cofactor. Molecular modeling suggests these modifications optimize the geometry of the radical pair mechanism, potentially enhancing the detection of weak magnetic fields. The increased expression levels in both retinal and pineal tissues indicate a synergistic enhancement of both magnetoreception and circadian regulation. Evolutionary implications. The strong selection signature around the CRY1 locus suggests this trait has been under intense artificial selection during the development of the best kittle lineage. The reduced heterozygosity rates indicate a selective sweep, consistent with the breeding practices employed in developing this elite racing line. This finding provides a remarkable example of human-directed evolution in domestic animals. Performance enhancement mechanisms. The enhanced CRY1 expression appears to confer several competitive advantages. Improved magnetoreception. Enhanced sensitivity to magnetic field variations. More precise detection of magnetic inclination angles. Reduced susceptibility to electromagnetic interference. Optimized circadian regulation. Better adaptation to varying day lengths during racing season. Improved recovery from temporal disruption. Enhanced energy metabolism regulation. Advanced navigation integration. Superior integration of magnetic and visual cues. Enhanced hippocampal spatial memory formation. More efficient processing of multisensory navigational inputs. Future research directions. Several promising areas for future investigation have emerged from this study. Detailed structural analysis of the CRY1BK protein variant using cryo-EM techniques. Investigation of potential epistatic interactions between CRY1 and other navigation-related genes. Development of genetic markers for selective breeding programs. Examination of potential applications in other racing breeds. Conclusion. The dominant expression of CRY1 in the best kittle family represents a significant advancement in our understanding of avian navigation genetics. The identified genetic variations provide a molecular basis for the superior racing performance of this lineage and offer valuable insights for future breeding programs. These findings have broad implications for both competitive pigeon racing and our general understanding of magnetoreception in avian species.
Get my main racing system, just email me direct. I'm an experienced ex-pigeon racer from England, and I can offer valuable insights and guidance on all aspects of pigeon racing, from breeding to racing. During my racing days, I managed a small team of no more than 70 pigeons, including stock, young birds, and old birds. It was not uncommon for me to send as few as 6 birds to a race and still secure the top 3 positions out of up to 2,500 pigeons in my club and federation. My race distances typically ranged up to 300 miles, and I consistently achieved top 5 placements in my club. My expertise extends to the art of selecting excellent breeders, including evaluating pigeons based on their eye sign characteristics. I firmly believe that true champions can only be bred from top quality stock, and I can guide you in identifying and acquiring such pigeons. I understand that many pigeons for sale are advertised based on their lineage or pedigree, but I emphasize the importance of assessing the bird itself rather than relying solely on paperwork. As part of my offer, I invite you to share photos of your pigeons, including their eye sign and wing characteristics. I'll provide you with free advice on racing and breeding based on my extensive experience and knowledge. Additionally, I will share auction links to high-quality breeding birds that have the potential to produce winners in your loft. Here's what you can expect to receive from me. A comprehensive Word document containing valuable insights and strategies for successful pigeon racing, including specific racing methods for both old and young birds, as well as general advice. Private YouTube videos sent to your email, covering various aspects of pigeon racing, from breeding to race preparation. Detailed recommendations on supplements and additives to add to your pigeon's drinking water, with scientific evidence supporting their effectiveness. Similar products are used by professional athletes and racehorses to enhance performance. Assurance that your pigeons will race home faster, provided that you have quality birds to begin with.